Hello friends, welcome to this video about the 1's complement and the 2's complement representation of signed binary numbers and their conversion method. As you know, signed binary numbers are those provided with a sign, and so include positive as well as negative binary numbers. The objective of this video is to explain what is the significance of the 1's complement and 2's complement of a number, and how the signed binary numbers can be represented in the 1's complement and 2's complement form, as well as what is their conversion method. As you know, a computer system is essentially meant to perform computation, and in that sense, the arithmetic logic unit forms the basic heart of the system. Computers are built using tiny electronic switches made with transistors. These switches, they can be turned on or off. They can be in two states, so we can use them to represent the digital 0 or 1 and to implement a model of binary numbers system. Binary numbers can be represented in either an unsigned form or a signed form. Unsigned binary numbers are represented without any sign convention, while the signed binary numbers can represent both positive as well as negative numbers. But here there is a challenge. How to do in a computer? Computers do not know about the negative sign. Computers only know 0 and 1. So, how to express negative numbers in binary? How to convert a positive number to negative? To convert a positive number to negative, the method consists of two consecutive steps. The first step is the direct sign step, that consists in adding a digit in front of the number, so that if the number is positive, we add a 0, and if the number is negative, we add a 1. The second step is called the 2's complement step, that consists in transforming the number obtained in the first step by first changing each bit with its complementary. The number obtained is called the 1's complement, and second, adding 1 to this 1's complement, and the new number obtained is called the 2's complement. Let's see an example. Let's see how to convert the number 7 into negative. 111 is the number 7 in binary. The first step is to add a 0 in front, because the number is positive. The second step is to change each bit by its complement. So 1 is 0, 1 is 0, 1 is 0, 0 is 1. And we get the 1's complement. And adding 1, we get the 2's complement. The result is 1001, which is minus 7 in 2's complement form. Let's verify. This is the verification. The result is minus 7, so it's okay. The minus 1 here, it is because it is associated to the negative sign. And the 3, it is because it is located in the third column. Column 0, column 1, column 2, column 3. So the result is correct. Let's see some questions. The first question is Why the direct step is not enough? Remember, the direct step is adding a 0 or a 1 in front of the binary number. The answer is because this only step does not work very well for computers, especially when performing operations such as addition or subtraction, and can lead to erroneous results. So the challenge for engineers was how to find a new strategy to handle negative numbers. This new strategy is based in the concept of complement number. That is how the two additional steps were introduced. The 1's complement, that means changing each bit by its complement, and the 2's complement, that means adding 1 to the 1's complement. Attention! Please note that 2's complement is not changing each bit 2 times. The second question is, why is 2's complement used? The idea of the 2's complement is very powerful, because now we can represent a positive number as it is, and a negative number by its corresponding 2's complement, and we can operate with them together. For example, a minus b is equal to a plus minus b. Now, substituting minus b by the 2's complement, we have is equal to a plus 2's complement of b. In this way, to perform a subtraction, we can use the same logic circuit for an addition. And the third question is, what are the advantages and disadvantages of using either 1's complement or 2's complement? The advantage of using 2's complement is that there is only one possibility for the number 0 representation, whereas the 1's complement has the disadvantage that it results in two possibilities for number 0 representation, plus 0 and minus 0. From the point of view of the complexity of the logic circuit to convert a number into its 1's complement, a logic NOT gate circuit is enough. Whereas to convert a number into 2's complement, we have to add 1 to the NOT logic circuit. Finally, all questions considered, the 2's complement is the method most generally used, and it has been confirmed as the most common method of representing the signed binary numbers in digital circuits. Another important aspect of the signed numbers is the concept of range. Computers are defined by the number of bits they can manage. 16-bit computer, 32-bit computer. To handle unsigned numbers only, all the bits are available to represent the magnitude of that number. But to handle signed numbers, we need to dedicate the most significant bit to the sign. As a consequence, we lose in range, but we gain in the fact that now the computer can also handle negative numbers. Example: a computer of 16 bits has 1 bit dedicated to the sign and 15 bits dedicated to the number. This is the sign bit, either 0 if it is positive or 1 if it is negative. And these are the rest of the bits. In the unsigned number representation, when we are representing integers, with n bits we can represent numbers from 0 up to 2 to the n minus 1, so a total to 2 to the n numbers. Example: with 3 bits you can represent integers from 0 to 7. These are the binary numbers. In the signed number representation, that means number with a positive or negative sign, we can represent numbers from plus 2 to the n minus 1 to minus 2 to the n minus 1, taking into account that plus 0 and minus 0 is the same number. Example, with 3 bits you can represent the integers from plus 3 to minus 4. These are the binary numbers. Note that the range of the positive numbers has been reduced from 7 to 0 to plus 3 to minus 4. The reason is because the most significant bit has been dedicated to the sign. Note also that the negative numbers are represented in 2's complement form. Conclusions. In summary, the 2's complement is the most common method of representing the sign binary numbers in digital circuits. To find the 2's complement of a number, we find first the 1's complement and then we add 1. The advantage of the 2's complement is that we can use the same logic circuit to perform addition and subtraction. In n bits computer, the most significant bit is dedicated to sign representation, 0 if it is positive, 1 if it is negative. And as a consequence, we lose in the range of positive numbers, but we gain in the fact that now the computer can also handle negative numbers. Thank you very much for your attention. Have a nice day. If you like this video, please hit the like button and subscribe for more videos.